Hello and welcome to Mr. Regaler and Mr. Glennon's Halloween Science Surprise. Unfortunately, you are not able to be in the room with us, so the next best thing we can do is share what we would have done with you and let you experience it through our eyes and through this camera. First off, today's warm-up was about sublimation. Do you remember what sublimation is? I know you learned about condensation and evaporation and precipitation, but sublimation, as you should have learned, is when a solid goes right to a gas. It skips the whole liquid phase. A lot of you have seen dry ice before, but this is what it looks like in its form. And again, as we talked about in the warm-up, dry ice is really not dry, and it's not ice, it's frozen carbon dioxide. And so right here, the steam or the smoke that you see coming off is really just carbon dioxide that was solid, and it's going right into a gas, and it's cooling in the air, and you can see it, and we are going to do some fun things with it. The first, you'll see I'm wearing gloves because it is Mr. Galler. How cold is this guy? Negative 275 degrees Fahrenheit. It's super, super cold. Listen to this.
What is that you have on there?
It's a coin. It's a quarter. And what's happening? Oh, now the coin. So when you heard it, now this coin is frozen. When you first touched it, the coin was warm, and the dry ice was so cold that it froze it.
Here, I have two more.
This is a frozen.
It's amazing how quickly it goes.
Yes. Ready? All right. I'm going to be really quick.
Here, I'm going to come and get close up.
Close up. And then it's stuck.
All right, so dry ice is amazing. Like Mr. Glennon says, it goes from a solid straight to a gas. What do you think happens if that is put straight into, all this is colored water? Okay, that's a good guess. Let's see. Let's put your guess to it. As you can hear, it's vibrating. And the gas you can touch with your hands. The dry ice itself, never touch, ever. But dry ice is something that you can get from Myers, and grocery stores, some have them, and some, Walmarts have them. Not all have them, but you can touch the actual dry ice. Second question.
The steam.
The steam.
Not the
or the water. You just
vapor.
can't touch the piece. Like if this was a drinking container, which we'll show you later, you can actually drink it as long as your lips don't touch that.
Could they still go out and buy this for Halloween?
You absolutely could buy this pre or post Halloween. You could do this.
Are they going to be able to find it easily?
Right now, currently there is a pandemic going on, so CO2 is in a
short supply.
Short supply. However, other years, and it might come back just kind of like the toilet paper thing, I guess. CO2 and toilet paper of COVID. So, don't even stop it. We'll just keep going because I can chop anything.
Yep.
Now, you can see what it does when just water. You can see that the bubbles it's making on the bottom, it's like a little bubbler. Like a little jacuzzi, basically, it's making the bubbles because the gas is coming into the water, obviously, and that makes the bubbles. What do you think is going to happen when I put in a piece of soap, this is just regular dish soap, into here?
Okay, it's gonna freeze.
Let's put I got to make a small enough piece that it goes in. Whoa! Whoa! Like a volcano, except these you can actually touch. And again, we wish you were here with us, because you legitly could be touching and playing with this. This is a way cooler volcano than the baking soda and the vinegar, I'll tell you right now.
Does it make a difference if the water is warm or cold?
It does make more bubbles when it's warmer. However, it still works when it's cold, but the warmer it is, the better the suds. So it's just kind of a fun little thing to do. I'll put it in this one too. Again, if you ever do this at home, make sure you use gloves. or cups to pour stuff in. The bubbler and the bubbles. All we're using is food coloring here to make it look kind of cool. It's like a dinosaur. Like I said, you can touch, you can breathe it in, it does not harm you.
Can you put it on your hand?
You can put it on your hand. If you're wearing gloves, eventually I'll show you a cool thing that you could do. You can get it on your shirt. The problem is our hands have little individual ripples that you can't see because they're so small. And once they touch bubbles, it pops it. But like cloth and things like that, you're able to hold them on. What do you think happens if we put a balloon over the cap of the flask? So let's put in a little of the dry ice. That's a lot. Just so you know, if you're doing this at home, a little bit goes a long ways. Can't tell if it's going to pop or if it's going to pop off the top.
If you want to hold the bottle, make sure it's not going to fall over, will it?
I don't think it will.
You want to get closer?
Or that might be all it does.
I
can't tell if it's still.
Looks like a light bulb.
It doesn't. I've got an idea.
All right.
All right.
We're gonna let that. Let's see
we'll
what
just
that.
Push it off to the side.
Yeah. All right. I got some in there. All right.
I definitely would pour water. Are you gonna go that way?
It's leaking out.
Zooming out. So I feel it's gonna pop up and go high. Woo! Oh, we made it in the jar, I think.
Oh, sweet.
I'm gonna try to make one ginormous bubble out of this. Like that goes over the entire top. If you ever do this at home, all this is soap and water. You mix it together with the piece of cloth. And you're trying to get one large bubble. So you want to get some soap all over the rim. And then we're just trying to stretch it out. It's kind of like when you blow a bubble at home.
Almost.
No, it should have worked. Oh, look into your future, kids. You will start to do your homework.
No.
No, that's wishful thinking.
Oh, yeah.
Wishful thinking. But yeah, that's a pretty good bubble.
That is good. You can see the carbon dioxide gas coming from it. And then there we go.
In the words of Bill Nye, science rules.
Science so rules.
Oh! We'll do one more.
Yes, yes.
Again, if you do this at home, I've found over the years that putting a little soap on the top of the rim makes it a little easier, and then you want to pull it as tight as you can to try to make that one continuous bubble.
Ooh.
Yeah! Why do you think this one's going faster? What was different between the two? This second one, I have a much bigger piece of dry ice put in there, so it's putting much more gas into the water. It's going to look like
boom! It kind of imploded.
So that is the giant bubble. Just explain what.
All right. I'm back. And I have 3 film canisters, and I was curious as to what happens with the gas and pressure. Because when you increase the gas in a small container, the pressure should expand, and I'm anxious to see if we can pop off any of these film canister lids. So I'm gonna get a couple in there.
Woo! It's quick. I didn't think it'd be that quick. Let me zoom in on this.
Woo! 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 Maybe less water. Oh, I put less water in, so.
Oh, that one I missed it. I was zoomed in on the other one. Okay, now I got them both. We just saw the lid come in.
I don't think I have enough water in this. I can see the cap is mounted, but
Don't slip and fall. We're getting a lot of water.
oh, there we go. So not enough water. So now that I put
Zooming
the
in.
water in, maybe not enough water.
Maybe not enough dry ice.
No, there's ice in there. It's just. Let's try one more time. Ah. I think it's all evaporating before I can even.
Where's the
Yeah, I
other-
see the dry ice in there.
Here, this one's new.
All right. Try this. Let's try water first. Pour in the ice. Yeah, I can't even.
It looks like the train top of a steam engine.
That's all I got.
It's pretty cool, though. All right, for our last one, made this. You can buy it on the internet for like $50, or I made this out of parts from Home Depot for about $3. So all it is a cylinder. I put a hole through it, a spigot on it, and a piece of tubing, vinyl tubing. You will need a little bit of soap in a container, and then you're just going to add water. Just make sure when you fill, if you do make one of these, you have to fill the water level so it's below the spigot. Put in your dry ice. I'll go big or go home. So I'm putting in a big piece. Woohoo! Can you hear it? My special potion. If you seal it off, like the little engine that could. Now, if you want to make bubbles out of it,
We like
you have to have the lid off and then get this a little bit in the soap.
Oops, sorry. There you go.
And then I might actually gone with too big of a piece. It might be pushing the bubbles too hard.
Oh.
So you're actually doing scientific method because when it's not really
There!
a problem, it's a question. How can I
I've
get?
got a bubble maker, and you'll see
There.
that they bounce. If you were in the classroom, I'd be putting it in your hand, dropping it on you guys. So cool! You can catch them. Now, what's the difference between a bare hand and a shirt? if you remember from earlier, your hands have little bitty things on them.
Ridges.
Ridges will pop them where the shirts, the cloth, does not, so it can bounce. If you put down like a towel, you could catch it on them.
Prove it.
Go Lady Elks.
Woo!
Hook 'em Elks. Now it's gonna, finds any sort of ridge, it's gonna pop them, but it's a cool little bubble maker.
So you think if somebody had little brothers or sisters at home, they would think this is really cool?
You seen this on my head?
Oh. It's not, it's just, bubbles.
I'll cut this part and we can go back.
Maybe it's all the hair that's making them break. That's off.
And finally, like all good lessons, all this is any beverage in this, you can cheers.
Cheers.
Science rules.
Tastes like victory.
Thanks for tuning in. Click like if you like this